بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 5.2, the definite integral. Question 4, evaluate the Riemann sum for this function f of x equals 1 over x from 1 to 2 with 4 terms. So we know the graph of 1 over x, and from 1 to 2, if x is 1, then 1 over 1 is 1, and if x is 2, then it is half. 1 over 2 is half. So it's a curve connecting these 2 points, and we have this region, okay? This is the region we need to find the area of. Uh, Let me make it bigger, because we are going to divide this area. So this is 1. Let me say that this is 1 and this is 2, and it is 1 here and half here. So this curve, and this is the region from 1 to 2. Taking the sample points to be right endpoints, give your answer correct to 6 decimal places. Explain what the Riemann sum represents. 4 terms. 4 terms, so we will take 4 rectangles. Delta x is b minus a over n, which is 4. So 2 minus 1 is 1. 1 over 4 would be the length or the width of each rectangle. So 1 to 1 over 4, then 1.5, then 1.34. So these are the 4 rectangles. If we are going to use the right endpoint, then these 4 rectangles would be there. Now, Riemann sum would be R4. We are using the right endpoint. 1 over 4 is the width. And now the length or the heights of the 4 rectangles, f of 1.25 plus f of 1.5 plus f of 1.75 plus f of 2. And we evaluate using the calculator and find the answer. Of course, the function here is 1 over x. So this is 1 over 1.25, 1 over 1.5, 1 over 1.75, and 1 over 2. Please use your calculator and find the answer. Now, repeat part A with midpoints as the sample points. Well, in this case, if this is 1 and this is 2, 1 here and half here, this is a curve and this is the region. Okay. Now we will divide into 4 rectangles, but we will use the midpoint to draw the rectangle. So this is the first rectangle, and then the midpoint, and this is the second rectangle, and this would be the third rectangle, and this would be the fourth rectangle. We need the midpoints. So we have, this is 1 and this is 1.25, and this is 1.5, and this is 1.75, and this is 2, but we need to find the midpoints. The midpoints are here. Okay, so how to find the first one? We add 1 plus 1.25 and divide by 2. We find the average. So if we divide, we get 1.125. 1.125. So this is the first midpoint. So in this case, we will have M4. The delta x doesn't change. It is 1 over 4, but the heights of the rectangles changes because we are going to use the midpoint. So it is f of 1.125 plus f of. Now we add the length, which is 1 over 4 or 0.25. So we have 1.375 plus f of 1.625, just adding 1 over 4 to each midpoint, and then 1.875. Or if you like, for the last one, for example, you add like here 1.75 plus 2 over 2, you will find that the answer is 1.875. And now you use the function, which is 1 over x, to write the values of f. This is 3. And then you use your calculator to find the answer. And do not forget to put your answer correct to 6 decimal places. So I can do at least one of them. I will do the first one to for you to check your answer and to see how to put it to correct for 6 decimal places. So here the answer would be 0.6345. How many decimal places? 5. Now the sixth decimal place is 3, and then I have 8 after 3. So correct to 6 decimal places, I will change 3 to 4 because after 3 I have 8 in the calculator. So this would be the answer. So please use the calculator to find the area in this case, or the estimation for the area in this case. The second example, question 22, express this limit as a definite integral. Well, we know that the formula for definite integral, the definite integral of from integral from a to b f of x dx is equal to the area is equal to the limit of the Riemann sum from 1 to infinity f of x I delta x. So here this limit is given, okay? The limit is given, and we need to express this limit as a definite integral. So the right hand side is given, and we need to write it as an integral. Well, the limits of integral are given, so it's from 1 to 3. And how to find f of x? It is similar to this without I. So this function here, this will give me f of x. F of x is exactly this one without I and without the star. Okay. So this is x squared plus 4. So this is f of x. And then you put dx. So that's the answer. We expressed the limit as a definite integral. Use the form of the definition of the integral, which is this one, this one, okay, to evaluate this integral. We first find delta x, which is 3 minus 0 over n, and we find xi, which is a, in this case 0, plus I delta x, so it is 3I over n, and f of xi would be xi is 3I over n, so it's 5 times 3I over n plus 2, because this is f of x. So we replace x by 3I over n. Now let me find the summation of f of xi times delta x. Okay, so it is summation of 5. 5 times 3I is 15. 15 I over n plus 2 times 3 over n. I will expand. So I will have 3 times 15, 45. I over n times n is n square, plus 2 times 3, 6 over n. Well, then I will write it as 45 over n square, taking the constant outside, summation I, plus I can take 6 over n outside or leave it inside. If you take it outside, there will be 1 inside. Now this would be 45 over n square, and summation I by the formula is n times n plus 1 over 2, and here 6 over n, and this summation is equal to n. If you have any problem here, please watch the video about section 5.2, okay, because these are exercises about that section, so we are just using the formulas in that section. So n cancels with n square, and I will have 45 over 2, okay, and n square cancels with n, and I have only n here and n plus 1 here, and here n cancels with n, and I have 6. Now I can find the integral, the definite integral from 0 to 3. By definition, it is the limit when n goes to infinity of the Riemann sum, which is 45 over 2 n plus 1 over n plus 6. Now the limit of this when n goes to infinity is 1, because we cancel 1, n over n is 1, we take the highest power. So the answer is 45 over 2 plus 6. I can check my answer by using the definite integral button in the calculator. So I ask him to find the integral from 0 to 3 of this function, and I find that the answer by the calculator is 57 over 2. So is 45 over 2 plus 6 equals 57 over 2? You can check the calculator, and yes, the answer is yes. So our answer is correct. Another example, similar to our example, delta to the previous one, delta x 2 minus 0 over n, xi has a formula 0 or a plus delta x times I. Now f of xi, the function, this is the function now. So f of xi would be 2 times xi, which is 2I over n minus 2I over n all cube. So let us find the summation, or Rn, the Riemann sum. It is summation from 1 to n f of xi, which is 4I over n minus 8I cube over n cube. If you raise this to the power 3 times 2 over n. Okay, I will expand this and write it as 8I over n square multiplying 2 over n times the first term, and then 8 times 2 is 16I cube over n to the power 4. All right, 8I over n square and 16I cube over n to the power 4. Then I will expand the summation, taking 8 over n square, the constant outside, and I will have summation I, then minus 16 over n to the power 4 is a constant, and I will have summation I cube from 1 to n. Now this is equal to 8 over n square. Summation I have a formula for it. And summation I cube, I also have a formula for it. It is the square of this. It is n square times n plus 1 square over 4. Now 8 over 2, let me write it here. 8 over 2 is 4, and I will have n plus 1 over n because n cancels with n square, and 16 over 4 is also 4, and canceling, I will have n square below and n plus 1 to the power 2. Now the integral would be the limit. So this integral from 0 to 2 of 2x minus x cubed delta x would be the limit when n goes to infinity of the Riemann sum, which is 4 times n plus 1 over n minus 4 times n plus 1 square over n. Now if we use the limit of this is 1 because the highest power is n over n, so it's 1. And the limit of this is also 1 because the highest power in the numerator is n square, and the highest power in the denominator is also n square. N square over n square is 1, so it's 4 minus 4, and the answer is 0. I can check my answer using the calculator. I write integral 2x minus x cube, and I put the limits of the integral from 0 to 2, ask the calculator the answer, and the answer is 0. So this integral would be 0, which means here, if you sketch the graph of this function, part of the region from 0 to 2 would be above the x-axis, and part of the region would be below the x-axis. If you subtract the area above minus the area below, you will get 0. Okay, another type of questions, evaluate the integral by interpreting in terms of areas. So we need to graph this area and find the area of the region. Graph the region represented by the function. I will use making, I will make it easy to myself, easier, and I will divide this integral into two integrals. So it's integral negative 3 to 0 of 1 times dx, or just dx, plus integral from negative 3 to 0 square root of 9 minus x squared dx. Now here the function is 1, and this is the graph of y equals to 1. I need it from negative 3 to 0. So this is the area I need to find, uh, the region I need to find the area of. Well, this is a rectangle. The height is 1 and the width or the length is 3. So the area is 3 times 1. So the area here is 3. While this one is half a circle, the upper half of a circle. If you write 9 minus x squared below the root, if you call it f of x or y, and square both sides and take x squared to the other side, you will find that this is a circle with center 0, 0 and radius 3. Since y is positive square root, so this means that we are talking about the upper half of the circle. But the region is from negative 3 to 0. So he is only talking about this part of the graph. So we need to find the area of this region. Well, this is quarter the circle. So what is the area of the circle? It's pi r square, but r square here is 9. So it is 9 pi. Now the area of quarter of the circle would be 9 pi over 4. So this is the required answer, 3 plus 9 pi over 4. You can check your answer also using the calculator. Here we have absolute value, and remember, absolute value has two definitions, okay? Either it is 2x minus 1 or negative 2x plus 1, when 2x minus 1 is greater than 0, or 2x greater than 1, or x greater than half. So actually here x is greater than or equal to half, and here x is less than half. So if this is 1 and this is half, so at half the function is 0, okay, and at 1 the function is 2 times 1, 2 minus 1 is 1. So this is the first part of the absolute value. And at 0, which is less than half, also the graph, the y value is 1. Here 0 plus 1 is 1. So this is the graph of the absolute value, okay? And this is the region we need to find, this one. We need to find the area of this region. Well, this is a right triangle, and the area is half times the base. The base 1 minus half is half, times the height, which is 1. So this is the area of this rectangle, and it's also the area of this rectangle because they are similar. So the area would be 2 times this, okay? Area of this plus this one, or 2 times. So it would be half, because 2 times half is 1. So the answer is half. So this area is half. And again, you can use the calculator to check your answer. Evaluate this integral. Integral from 1 to 1 for any function would be 0, because it is from a to a. So delta x in this case would be 0. Write this as a single integral. I have 3 integrals. The first 2 integrals, I can write them as one integral from -2 to 5, because here from -2 to 2, from 2 to 5, so I can write it immediately from -2 to 5 f of x dx. And I have minus integral from -2 to -1. But I will change the limits of this integral. And by changing the limits, I will have a negative sign. Negative, so it would be negative times negative would be positive. So I can write it positive from -1 to -2 instead of -2 to -1. Why I did that? Because I have -2 here and -2 here. Okay. So now if you switch this, if you start from -1, so I have integral from -1 to -2, then integral from -2 to 5. All right. So I can write it as one integral from -1 to 5 f of x dx. So this would be the answer. Also here, I have integral from 2 to 8, 2 to 4, 4 to 8. Well, I can write the integral from 2 to 4 plus 4 to 8. I can write it as a single integral from 2 to 8. All right. And what do we have? From 2 to 8, I have it. That's 7.3. From 2 to 4 is 5.9. And he wants me to find this integral. Okay. So this integral would be, it would be equal to 7.3 minus 5.9. So the integral from 4 to 8 of f of x dx would be 7.3 minus 5.9, and that's equal to 7 over 5, or just 1.4. Finally, the last question. How to find this integral from 0 to 9? Well, we know that from the properties of definite integral that I can write this integral as 2, I can take 2 outside, times the integral from 0 to 9 f of x dx, plus I can take 3 outside. I can distribute the integral because I have plus. So 3 times the integral from 0 to 9 g of x dx. So I can write this as this one. And now in the question, he gave me this integral. He said it is equal to 37. And also he gave me this integral, and he said it's equal to 16. So now the required integral would be 2 times 37 plus 3 times 16, which is 122. Thank you very much, and have a nice time and study hard.